Hello, I am audible. Hello. Anybody is there?
Yes, sir.
My screen is visible, Babu?
Yes, sir. Yes, sir.
Yeah. Okay, fine. You see, today there is a artificial bee colony algorithm to solve some of the optimization algorithms. I can say that power system optimization and all to minimize the cost or loss or voltage deviation and improve the stability. For many reasons in optimization, power system optimization, we required some of the heuristic algorithms. In that, I chosen one of the algorithms, like artificial bee colony algorithm. Many algorithms are there, like cuckoo search algorithm, particle swarm optimization, ant colony algorithm, harmony search algorithm, like that water flow algorithm. Many algorithms are there, lakhs of algorithms. These are all heuristic algorithms or natural inside algorithms. So using that, we can able to solve our problem. So before using our power system problem, not only power system, it is in HVDC transmission like that. We can see one algorithm. I will take as one problem, like a test function and all, how to solve that problem using this algorithm or minimization of the problem and all. And for that case, I selected as artificial bee colony. This I will show you some of the journal papers. Like you can see that elsewhere paper and all. This is one of the latest journal only in 2020. Optimum reactive power dispatch for real power loss minimization and voltage stability enhancement using artificial bee colony algorithm. So once if you know this algorithm, we can apply that into the our real problem. So like a power system problem or anything. Not only this power loss minimization or cost minimization you can use it, and the loss minimization and then emission minimization and voltage stability enhancement and like that, and voltage deviation minimization. So many of the objective functions we can take it from power system, like in real system you can take it, IEEE 30 system you can take it, or normal running system like a Tamil Nadu power system or Maharashtra power system, like that. Many states, any of the state real data you can take it, and you can able to find what is the cost of generation or what is the minimum loss or what is the voltage deviation, like that. Many of optimization parameters are there. You can choose that parameters and try to implement using this algorithm. Here the algorithm not only artificial bee colony, teaching learning algorithm is there, like the teacher and student in a class. So how that will be behavior, that also you can take it. So that's what I'm covering little bit all the areas in electrical engineering, like previous of some of the classes that covered power system as well as power electronics. And now we can see that optimization techniques or algorithms. Using that, you can implement any of the journal paper. Now I will show you how we need to solve using normal problem. Suppose there is a function. Let's consider as f of x is equal to x1 square plus x2 square plus x3 square and so on. Let it be any of the parameter you can take it, or we can take it as summation I is equal to 1 to 10 xi of xi square. That's it. Where I is equal to 1 to 3 and so on. some 10 or 20 or whatever you can, or any standard test functions you can take it, and to find minimum function value, or f of x is equal to something equation we are taking, and that equation to solve, as you know that in normal mathematics and all, how to find minimum cost or minimum value of a function. Like we are differentiating and equating with respect to 0. That is all conventional methods. Many of the conventional methods are there to find minimum cost or minimum value of that function. Similarly, in this aspect also, we will take it as a one equation or a function. In that case, what we will do is how to solve by using artificial bee colony. After that, once if you aware this, later on you can take it as a power system problem. Simply replace that function by power system function. Let's consider what are the power system functions. First one is a cost function. As you are aware that in a what you call it as in power system subject, there is economic load dispatch or a cost function. F of PGI is equal to AI PGI square plus BI PGI plus CI, like that. There is a, I think, power system optimization, power system operation and control, or power system analysis. Somewhere you will get that expression. So that is our expression to find cost of the power. In that case, A, B, A, C, I are all the constants of the particular generator, and PGI is going to be vary how much power is going to generate in the particular unit. Let it be PG1, PG2 and so on. In a power system, any particular system, if it consisting of 5 units or 5 generators, each generator cost is depends on their internal parameter, because whether it is near to the coal mile or long distances, like that many parameters. So they will give the parameters, constant parameters for the particular generator. And now if you generate some 10 megawatt power through generator 1, and another generator is 20 megawatt, and third generator may be 50 megawatt, like that. And what is the cost of a generation? Then what you will do in general expression, we will simply substitute that using as a f of PGI, A1 PG1 plus B1 PG1 square and so on. That expression, the PG1 value will substitute, A1, B1, C1 value will get it. That will give for the first generator cost. Similarly, plus and so on. You can use as a PG2. Then you will use PG3 and so on. You will get the total cost of a generation. So that is what normally you can able to find what is the cost of a generation. In that case, our aim is to minimize the cost of a generation. Then among the 3 units of a generator, which generator is going to generate how much to get as a minimum cost? That is our algorithm will do that. Algorithm will decide what is the value of PG1, PG2, PG3, so that total cost of a generation is going to minimize. So that is the advantage of a algorithm. So like in this case, we'll take it as artificial bee colony algorithm. This is one of the algorithm. Using this algorithm, we are finding what is the value of PG1, PG2, PG3, so that you will get minimum cost. If your object is a cost is a minimization of your generation cost, or else your object is loss minimization. In that case, what will happen? You can see that you take it as a loss function. As you are aware that in a power system, even Newton-Raphson and all, we are finding what is the total system loss. How will you find the system loss? I think you recall in Newton-Raphson method, line flows. So current or power flows from bus 1 to bus 2 and bus 2 to bus 1. Like that, all bus line flows, if you calculate, if you sum it, whatever the value you are getting, that is nothing but a power loss in a system. Like 5 bus system is there, in each 5 bus system there is a line 1, line 2 and so on is there. So each line flows you can find, you add all the line flows SIK plus SKI, if you sum it like that in the particular instance, uh, that will give the total loss of a system. So that is one of the aspects. So like that, if you consider as a loss, is that one. And similarly, stability enhancement. So any of the parameter, there is a equation. Simply you replace that equation, normal mass equation is replaced by that objective function, then you can easily solve any of the paper using any of the algorithm. If you are aware of the artificial bee colony algorithm, I want to do same problem or want to solve that problem using some other algorithm. Let that algorithm I consider as a some cuckoo search algorithm. How the cuckoo will behave, based on that there is a equation, and you can use that step by step procedure, you can able to solve that problem. That means it is more or less all the algorithms procedures are same except the mathematical equations. Automatically, if mathematical equations is changed, accordingly the coding also very simple. Whatever MATLAB code you are doing for any particular algorithm, you can replace that equation by some other algorithm equation, you will get a solution very simple way. That's why what I am suggesting is, I will explain this algorithm today, and if time permit, the tomorrow also I will extend this in mathematics, I mean what you call it as a MATLAB code also, and you keenly observe that, and you take it any of like this type of general problem, and if you try to solve it, so your very good project you can able to complete any of the existing journal like Elsewhere or IEEE or Springer. So like that, any of the journal paper you are able to solve using this type of, because many areas I am covering in particular interest, you can go to that area and pick up the journal paper and you solve through Simulink for power system, power electronics and all, or through MATLAB you can use power system problems and all. Like that, many areas you select that journal paper, appropriate journal, if you read once and twice you can easily understand how they are implementing, what is the algorithm, how to write a code. If you know simulation techniques of electrical engineering course, I think it is there in the elective. If you are familiar in that MATLAB code, we can easily solve this type of journal paper. It is a latest journal, that to Elsewhere journal. If we solve this, it is very good experience for you to solve. You can put it this as a project also. Now, I'll show you that is taken as a IEEE 30 bus system as well as the 57 bus system. These are all the standard systems. It is available, the data, everything is available in a literature. Simply if you type IEEE 30 bus system data, you can get it. So how many lines are there, how many generators are there, how many load buses are there, all the data and what is the impedance of the each line, everything you can able to find using this just available data only, and we taken two test functions and is solved using this algorithm. And now these are all the literature and all, in the sense the paper one what he proposed, and then these are all the basic methods, linear programming, what you call it as, will show you here in this paper 1, 2, 3 names indicate that they will show in the these numbers in a reference. In the end of the paper, you can see that this one is the paper using the optimal power flow by Newton approach. These are the conventional methods. So they will give the numbering here. This one is also the linear programming based optimal power flow. Newton approach method, and then reactive volt wire control dispatch. So many of the literature they referred, and they implemented their own proposed work. So this indicate within a brackets 1, 2, 3, and so on. We have to give it in our document. There we can able to represent what is your reference paper. So you have to write that reference paper here. And he is M.A. Abido. He is the person invented as a particle swarm optimization. Many papers he developed in the particle swarm optimization, PSO, or we call it as. If you want that also we will discuss some point of time. And now, so that is the literature, how to write the introduction part and that. And the last para, what they will do is how they are going to, in this work, you can see that last line, what he mentioned is in this work, recent evaluational algorithm called ABC, that is artificial bee colony, has been used to solve the dispatch, that is economic dispatch or whatever problems you want to take. And that is the first. All the journals will be like this only. Just try to understand how we can able to write the journal paper also. And the second one, we can see that problem formation. So problem formation, here the title itself they mention, the problem is you want to use as a reactive power dispatch for real power loss minimization and voltage stability enhancement. So all these are these objectives. So you want, you can change that objectives also. And here the first objective is a real power loss minimization. So one of the main objective is you want to minimize the loss, whatever may be the cost of generation, it is no matter. So there is a specific constraints as well as specific objective is there to solve the problem. Many objectives are there, but he taken I think 2 or 3 objectives. In that first one is a power loss minimization. So for that, so this is the power loss minimization. Just now I mentioned PK loss or PIJ or SIJ. SIJ will give as a real power as well as the reactive power, but he want only the real power loss. That's why 2.1 subheading you can see that real power loss minimization. That's why he consider only the PIK and sum of that, all the lines real powers if you add, that will give as a loss of the system. So in that case he used this formula, the expansion of this these parameters. These parameters will be obtained after doing Newton-Raphson and all. So now this is one of the objects. And second object you can see that 2.2 voltage deviation minimization. What is the voltage deviation? Everybody knows that there is a bus voltage must be as a fixed one normally. Why it is we want to maintain as a fixed is, and any particular bus there is a lot of load is connected to that. If that voltage is very, automatically load also going to fluctuate. So that is the reason you can say that the bus voltage you need to maintain constant. So we can see that what is the reference in general constant in the sense as a rated. Rated is in terms of the per unit. If you convert, I can represent as a 1 per unit. 1 per unit is a for suppose if it is a reference, and deviation whatever the actual value it is there, and the difference will give as a deviation, nothing more than that. Preferably there is allowable plus or minus 10% or plus or minus 5%, you can take it. Suppose if it is 1 per unit is rated, then you can take it as a like 0.9 to 1.1. So that means this lower side also some 10%, upper side also some 10%. So that is the difference, you can take it, or 5% also you can take it, 0.95 per unit to 1.05 per unit. So that is the some allowable limits, or you can say that. So this is the case they mentioned voltage deviation is a VI under that particular bus voltage minus reference voltage magnitude they mention. No, that means whether it is a lower side or upper side, it won't be matter. So we can see that this is our next objective function. So like that you can see that voltage stability enhancement. So the power system must be, for that is also called as L index. I think this all the things may be there in the power system case also. L index, you can define, this is the formula for there is a derivation also there, how to get this formula. At moment it is not required, only thing is use this formula how to solve your problem using artificial bee colony. That is only our object. So for that L index they used this one, using this function. This is our objective now. Only what I will explain is if function is f of x is equal to x1 square plus x2 square and so on, if I take that function I will solve using artificial bee colony algorithm. Now, if you want to solve this paper, you replace that by this equation. So then automatically same step by step if you solve, you can able to get it our solution. So these are the three objective functions we consider in this paper. One objective function is a loss minimization. Second one is a voltage deviation minimization. Third one is a stability enhancement. So using these three objectives we are able to minimize one by one, and later if we are familiar to solve one or two algorithms and this type of problem, you can able to solve multi-objective optimization as well. What is the multi-objective optimization? Here you can see that there is a loss alone you will minimize if I consider as one objective, and our voltage deviation alone you can minimize one by one. So either if I minimize the loss, other parameter we don't mind, it may be more voltage deviation also, or some other cost also may be more, anything we don't mind at all. What we mind is we have to minimize the loss if I consider this alone, like that. Second one, if voltage deviation want to minimum, I don't want to bother about what is the loss or what is the stability. But real case, I don't want to leave them as their value, like, because I want to minimize all the parameters, so that multi-object what it will do is at a time it has to consider some weightage for loss minimization, weightage for voltage deviation minimization, weightage for the stability enhancement. So like that, based on the user interest, like some small example, I want to buy a car. So what you will do? There is a lot of constraints are there. One must be the car cost must be minimum, or mileage must be good, or internal interior must be good. So all there may be a lot of things are there, but when you are pick up that particular car, you have to fulfill these things. When you are fulfilling, either somebody will take, I want minimum cost, whatever may be other parameters I don't mind, but cost must be minimum. In that case you will select one type of car, but some other customer will think that I don't mind of the cost, but I want as a luxury, then he will pick up some other model. So like that, many based on your objective the answer is going to vary. But some people will come with some certain objectives. I want mileage, I want cost aspect and comfortness, and all these three parameters has to be fulfilled. But while you are fulfilling that, there is a not equal priority. What they may consider, some 80% weightage is given to the cost aspect, and 20% or 10% weightage for the mileage, and rest of the 10% weightage may be comfortness. So if you do such analysis, all the three parameters has to be fulfilled, then you will pick up some other type of car. So like that, the same power system case also, all the parameters if you want to fulfill at a time, then the values going to change. Values means generation of generator 1, generator 2, all these things is going to be modified. So that is only the problem is going to be solved using our algorithm. So these are the three objects let's consider, and to fulfill that there is a sum of the constraints also we need to take care. So what are the constraints? Suppose you can see that like a car example, if I consider, I want a very luxury car. Then, but how much I can expend? There is some limitation. The cost must be let 10 lakhs to 15 lakhs or 20 lakhs to 25 lakhs. There is a limit will be there. Even though you are expecting as a luxury car, but while you are selecting that particular car, the cost should not be beyond that limit, like 20 to 25 lakhs, let's consider. So your cost of that must be within a limit. If it is not within a limit, your choice will not be valid. Whatever you pick up, it may not be, because you don't have that much money. Our constraint is like that. Like that, in this power system also, there is a lot of constraints are there. So what is this constraint? You can see that equality constraint as well as the inequality constraint. What is the equality constraint is, suppose any particular exactly I should meet that. Suppose some other power, let's consider how much power I want to generate. This power must be always equal to, the generating power must be equal to demand plus losses. It should not more than that. I don't want to generate more power. Why? Even if I generate more power, it is not useful. That is the constraint. I call it as a equality constraint. Whether it is real power or reactive power, you can see this statement by seeing here equation itself. You can come to know that PGI, any of the generator, whether it is a generator 1 or generator 2 or whatever you call it as. So in that particular generator, PG means generation, D means demand. So and now we can see that PGI, if you make this in the left hand side, I mean right hand side, you can see that PDI plus this. So what is this minus sign of equation? It is nothing but a loss equation. So this generation must be equal to demand plus loss. So that is our equation. Or if you keep all one side equal to 0 fashion, generation minus demand minus loss is equal to 0. That means sum of the generations is equal to the total demand plus loss. That is our constraint. It should not be deviate or in between. That's why it is very clear that you are fixing that. So this is, we call it as equality constraint. Not only the real power, you can consider reactive power also. These we call it as a equality constraint. Now you can see inequality constraint. What is meaning of inequality constraint? Suppose there is a generator is there, there is a bus is there, load terminals are there, reactive power is there, and transmission line capacities are there. So all these parameters, there is a slight variation also is acceptable one. So what is that slight variation? You can see that voltage. Voltage of this, any of the bus, you can consider minimum to maximum. That I told, no, the 10% or a 5% is allowable one. You can see that VI, voltage at that particular bus, ith bus, or you can say that first, second bus, third bus, or any of the bus in a system, the voltage must be always within a limit. Limit we can choose it, whether 10% or 5% or something. It is allowable one. That we call it as an inequality constraint. It may be 0.95 or 0.99 or 1.01 or 1.02, something like that, but it should not be beyond our limit. What is our limit? Let's consider 0.9 and 1.1. There is a 10% means 0.9 to 1.1. So in that aspect, you can see that always within a limit. That is one thing. And tap changing. I told in HVDC transmission also, before converter and after inverter, there is a tap changing transformers are there. Why these tap changing transformers? To adjust that voltage to maintain as a constant voltage or to make it as a within a limit. So for that, there is a taps also available in a power system. Some of the tap changing transformers are also there. that is also 10% or 5% you can fix it. The taps you can going to be changed. And reactive power limit also, generator reactive power limits, and then condensers also there, and these are the line capacity. Yes, I told no SIK and all. That means power flows from first bus to second bus, or second bus to third bus, and so on. Any particular line, what you can say is uh, all other what you mentioned, that the line capacities should not be increase your transmission line. So whatever, suppose line 1 to 2, I mean there is a one transmission line, that capacity is 100 MVA. You cannot transmit the power beyond that. That will be always lower than the thermal, that also called as a thermal limit. The maximum allowable capacity of a transmission line, that I call it as SI. So or SL, the particular line 1, line 2, line 3, and so on, anything. That is always less than or equal to SL maximum. So each line they will specify what is the rating of a transmission line. So while you are minimizing these of the objectives, you should not deviate over these parameters. You must and should fulfill this, then only you can able to minimize the cost, or you can minimize the loss, or minimize the voltage deviation, or improve the power system stability, or severity you can minimize. Like that, many of the parameter, while you are doing that objective satisfaction, you should not violate of any of the limits. So these are the we call it as a constraint. So up to now, any of the journal paper like this only. So but only this can change, and this should not be changed. These parameters will be fixed throughout your power system optimization. And now to convert that constraint, this inequality constraints to equality constraint, they used as a this Lagrangian and all. You can use that, or penalty function, and you are converting to the inequality constraints to equality constraint by make use of this objective function. And now we'll come to that artificial B algorithm. How this problem is going to solve using artificial B algorithm. So this algorithm introduction is given. Anyhow, I will explain this complete algorithm step by step process. At moment I will show you only journal paper, how the paper is going to write, how the result is coming, all these things. Then I will explain all in detail of artificial B algorithm. Not only ABC algorithm, many types of algorithms are there, but problem is same problem. You change that algorithm, and or you can mix the two algorithms, you can solve it, so that you can compare with different algorithms, so that you came to know that which one is better. And now there is implementation of ABC algorithm. There is a lot of steps they mention here, step 1, step 2, and so on. I will also show you all the things, and finally we can able to implement this algorithm to solve that problem for the IEEE 30 bus system they taken, and they make it as a result. You can see here IEEE 30 bus system. These are the parameters. What is the in this IEEE 30 bus system, there is, you can see that 1, 2, 3, 4, 5, 6 generators, means PG1 to PG13. We call it as a real power, how much it has to be generate, and these are the voltages. Up to this, these are the voltages, and this one is the taps. So there is a minimum and maximum, all the parameters are mentioned here. And now once if you implement that using ABC algorithm, you can see that ABC for IEEE 30 bus system, and also they compare this results with some other algorithms. This table shows that you can see one thing, control variables are this one, and some of the control variables they mention, and also they mention different algorithms. So this is the HSA harmony search algorithm, or particle swarm optimization, and ABC is our proposed algorithm. You just notice this, whatever may be the parameter you want to consider, using this algorithm, lot of algorithms they implemented same problem and they concluded here in this ABC algorithm with different algorithms. You can see that power loss. Our intention is to minimize the power loss, first objective function. As I mentioned previously, there is a 3 objective functions I shown. No? Yeah, this one 2.1 power loss minimization, voltage deviation, and then voltage stability enhancement. Same thing they solved using ABC and they presented result, but how to solve and all they cannot project all the things. Use the algorithm. You have to develop a code and algorithm flowchart also given. According to flowchart, you write a MATLAB code and implement that, and you just project only the result instead of all step-by-step implementation we don't require in a paper. If you do that, it will get number of pages will be more and more. Only thing is the results, but I will show that how to solve it. That is only for your case. So there is ABC algorithm they solved and they presented results directly here. But I will explain any of the algorithm. It may be PSO algorithm or ABC algorithm or harmony search algorithm or cuckoo search. Any of the algorithm. Once if you are familiar with any one, rest of the things also slight modifications are there, but procedure and writing code and all more or less same. Now you can see this consolidated statement of IEEE 30-bus system cost minimization. Linear programming method. These are all conventional method. If you use, I got the loss is 5.988 megawatt. This much power loss is there in IEEE 30-bus system. If I solve is a linear programming or evaluationary programming method, if I use 4.963 and so on, you can see that if I use PSO something 4.81 and harmony search if I use 4.7 and so on. And finally, if I use ABC algorithm, this is our proposed algorithm, I got the loss is 4.5804. That means it will give as a best solution. That result will show that suppose generator 1 is generating this much power. I think this, yeah, see that is not mentioned that the generator's result here. So if the generator 1 is generating this megawatt, generator 2 is this much megawatt and so on, if you are able to find using this algorithm, that values if you generate, the loss is going to be minimized when compared to other existing algorithms. So these are all the conventional algorithms, some of the heuristic also there, but once if you use that algorithm, we can find finally when you are comparing the rest of the algorithms, ABC algorithm will give as a better solution 4.58. So this is the best cost, or you can say the mean loss on the system if you use as a ABC algorithm. That's all the conclusion for that particular objective function. So what objective function? Loss minimization. Similarly, this is our power system. What they consider is a let I will show you. This is IEEE 30-bus system. If you Google it, this chart all the data you can able to get it. This is not a normal or user defined. It is already there in the particular power system. System is readily available. The data everything is available. Using that we are finding. So like that IEEE 14-bus system is there, IEEE 300-bus system, 1000-bus system. So lot of standard test data are available. Using that we are solving. Now you can see here I mentioned now how many real powers. You can see 6 generators. So in the diagram you can see 6 generators. So this is the 1, 2, 3, 4, 5, 6. So these are the 6 generator in which bus numbers also they mention here. You can see that bus number 8 is one generator, bus number 5 is another generator, bus number 1 that is a slack bus, bus 2, bus 5, bus 8, same thing you can mention here. You can see that bus 1, bus 2, bus 5, bus 8, 11, 13. So these numbers there is a generators are available. Like that you can able to find lines, number of lines also. You can count this is one line, this is another line, like that. So these are all transmission lines. So totally, I think 41 transmission lines are there in IEEE 30 bus system, 41 or 42. So just you can count it here. You came to know that how many transmission lines are here. And now that is one objective function. If you represent that convergence characteristics by increasing the iteration number, gradually the cost is going to be minimized and finally it will reach a stable. That is your cost. So this is our 4 point something. This is our cost of the generation. So now same 57 bus system they used. What I shown you in the previous diagram, that is a IEEE 30 bus system. But now we can able to see that IEEE 57 bus system again they used as a different algorithms, and finally they came to know that the proposed algorithm ABC is a best value when compared to the other parameters, that you can see that consolidated one here, cost minimization. Now you can see that system is more IEEE 57 bus system, lot of transmission lines are there. That is the reason you will get more loss. And if you further go to some other transmission system or power system, you will get some other value of the power loss. Here IEEE 30 bus system, we notice that how much we got 4.5, no? But if you go to IEEE 14 bus system, you may get 3 point something like that megawatt. So that is depends on the transmission system. If the bigger system, more transmission lines are there, then obviously loss is also more. And similarly here 57 bus system, you will get loss is a 24.1025 megawatt. But when you compare to other algorithms, same 57 bus system, other algorithms are showing 27.9, 27.8 megawatt and so on. But if you see the proposed algorithm will give as a best result. These only the conclusions. And now some other you can see that what is the power loss with different algorithms. They mention like this of graph also. These are all only for representation, nothing more than that. This table, whatever you show this table, they represented in a graphical fashion. That is only the graph. And the convergence characteristics for IEEE 30 bus system, enhancement of the voltage stability, and this one will be the real power loss, and this one will be as a voltage deviation. Like that, all the three objective functions they solved individually. They represented as a voltage stability one thing, and then real power loss, and then voltage deviation. So these are the three objective functions. And only thing is this total paper consisting of a three systems. One is IEEE 30 bus system they solved. Same code will be applicable for any of the power system. Once if you write code for any particular system, that same code will just modify the number of buses and all, automatically any of the power system it will work. Only you will give the data, that is what the generalized code you will write. So then automatically same code will implement for other type of systems also. Even large power system also same code will work out. That's why they mentioned two types of systems here. Three objectives they consider and they solve, they represented as a paper solution here. That's all the conclusion. No, they given very simple logic and they got as a elsewhere paper. It is a very top journal. You can able to publish your paper. So that much easy once if you familiar of any of algorithms, you can easily solve through power system. Now you can take instead of loss, no, if you take cost minimization, instead of this function equation, if you change to AI Pj square plus BA Pj plus CI, you just automatically will get the result for the cost value. This is a modification. Now instead of ABC algorithm, if you use some other algorithm, that is another way you can able to solve, and you compare of other methods already it is available in the literature. That solutions and your solution you can compare and show my proposed method is better than the existing, then automatically you will get one publication. So that much simple. And now this is the old paper he proposed. Actually, he is the inventor, Karaboga. He is the author for the ABC initially in 2007 paper this one, but he proposed I think 2005 itself. Later he modified further and further. Finally, he proposed another journal published. This paper is a Springer publication. This is also very good journal. And what he taken is, he is not taken the power system problem. He is taken as a mathematical equations or like a standard test functions. Any of the mass equation, normal functions that he solved with different test functions. That only he solved. You can see here. So these are all theory about the existing methods, SPAM optimization methods, all some of the existing methods he proposed. He explained simply, and then this is our proposed artificial bee colony algorithm. And then he solved using test functions. This is the algorithm. I will explain anyhow. This one is a benchmark test function he taken. This is one of the functions. What is the value of x1, x2, x3, and so on? You solve using your ABC algorithm. That is one function. This is another function. Like that, any of you can take your own function and you solve it and compare your results. That's it. You taken this is the third function. Many of the functions, this is the fourth function. Only once if you write the code for any of the functions, what modification is only this thing is going to be replaced. In a MATLAB code, wherever F1 is there, that is replaced by F4. That's all. Same program will run using ABC only. So that's the beauty of this MATLAB code. You can able to implement any complicated problems using our MATLAB code. So this is the F4 function, means different test functions. This is another test. So what he solved is he implemented all the test functions using different algorithms. So genetic algorithm used and PSO used and ABC finally. And this combination also used. There is a particle spam inspired evaluatory algorithm, that is the hybridization. Using these two algorithms he mixed and is shown. And finally the proposed algorithm is ABC. And he show the result. You can see, I will rotate this. Yeah, just a minute. This table, what is shown is same function 1, function 2, we taken 5 functions. No, each function is solved with different algorithms. So he used genetic algorithm, PSO, combination of these two, ABC. So all the things he solved, and finally he proven that ABC algorithm is better than the existing algorithm. That's all. He got paper. So this is the initial stage of ABC algorithm. Later, once the publication is come out, everybody will see that this algorithm is better when compared to some other algorithms. And what he will do is other researchers also will use that technology or use that algorithm for their own application. In our case, electrical engineers will use this way, and some other civil engineers will identify the best location of beam or something else. The mechanical engineer design size of that, minimization of the size to meet that much torque, all these things like that. Many types of applications we can use it using this algorithm. We can solve it. So now that is the one aspect of journal paper. Now we'll see that what is the ABC algorithm and what is the internal equations. All these things we'll see. And once if you are aware that algorithm, and that you can take it as one test function, just simple test function. I will take it x1 square, x2 square, or anything small, whatever we noticed in the previous journal paper also. Some of the 5 functions are there. No, any of the function also you can take it and you can solve it. And then once if you are familiar to solve the test function using this algorithm, this can apply your economic load dispatch problems as well. or optimal power flow, anything. So that is the procedure actually. Now we'll see that in our presentation, introduction, ABC algorithm, test functions, and MATLAB code. So I will use that MATLAB code also. I will show you how to solve the problem using that code. Code also I will explain in the next class. You see that this is the ABC algorithm, also called as artificial bee colony algorithm. Is the swan-based heuristic algorithm. Is invented by the Carboga in 2005 and optimizing the numerical problems. So I shown you his paper also. I think I shown you in the 2007, but his starting paper is 2005. Later he identified some of the mistakes in that or developments, and finally another paper he published in 2007 that I shown you in the Springer. And inspired by the intelligent foregoing behavior of the honeybees. This is all about honeybees natural inspiration. Like I told cuckoo search algorithm, how cuckoos will lay egg on the host nest, all these things. It is similar to crow nest. The cuckoos won't have their own nest, that will lay egg on the crow, or you can say that their nest. So how the best identification and the best suitable place, all these things come developed in the cuckoo search algorithm. And now in the ABC, the colony of artificial bee contains the 3 groups of bees. That means this is inspired by, I told no, it is honeybees. So based on their behavior, we are going to develop our this algorithm. So there is 3 groups of bees. The honeybees, they divided into 3 groups. So there is employed bees associated with specific food sources, and another bees are onlooker bees watching the dance of employed bees within the house to choose food sources. And last one is a scout bees. This is searching for food sources randomly. So this total group of honeybees are dividing into different groups. The total is divided into 3 groups. One is employed bees, onlooker bees, and scout bees. So both onlooker bees and scout bees are also called as unemployed bees. So this is a employed bees are a specific food source associated with a specific food source, and these two are also called as a unemployed bees. So we are dividing 3 groups. Initially, all food source positions are discovered by the scout bees. So because I divide 3, no, one is a employed bees, another group is onlooker bees, and third one is a scout bees. So initially what it will do is all food source positions are discovered by the scout bees. So the scout bees will identify the food sources. Thereafter what will happen, honey of food source are exploited by employed bees and onlooker bees. So what you try to understand the logic behind this, later it will come the equations and all. At the moment we divide 3 groups. What the division is employed bees, onlooker bees, and then scout bees. Initially scout bees will discover the food source, and next what will happen, employed bees and onlooker bees are exploiting that food sources, and will ultimately cause them to become as exhausted. So then what will happen, employed bees which was exploited, the exhausted food source becomes as a scout bees. In such further food source, once again scout bees will search that food sources. In other words, employed bees whose food source have been exhausted becomes a scout bees. So once the food source is exploited, that bees itself will try to search for the food source, that then that bees will call it as a scout bees. And this is the algorithm implementation, and one of the IIT Gauhati professor also they explained this in the NPTEL course. So that's why just I mentioned his name also. You can see that employed bees, onlooker bees, scout bees. these are the phases. While you are solving the problem, you need to consider all the three phases. First phase is employed bees. So what we will do is, employed bees are try to identify the better food source than one associate with it. Then what we will do, it generate a new solution using the partner solution. So here the solutions are, initially we will get some random solution, some group of solution. One we can consider as a modification, rest while you are getting as a new solution, like iteration process, nothing more than that, what you are doing in the Newton-Raphson and all. So in that case, once there is a what you call it as there is a solution, while you are getting as a new solution, we need as a one partner solution. Partner solution we have to select randomly. There is a 10 solutions are there, for example. One of the solution you choose randomly as a partner solution, and using that you will get it as a one new solution. Once let's consider here is a small requirement is there. Suppose our problem is we need to find our function is something like this. Let's consider for simplicity, there is a x1 square plus x2 square. Let's consider only this small thing, x1 square plus x2 square is our function. Suppose randomly I choose that x1 x2 value, some that we call it as a population. So this one is a x1 values, this one is a x2 value. So I chosen randomly 1 2 3 4 and 5 6 some solutions or anything, some solutions I taken. How will you get the function value? This one is a randomly selected the x values, x1 x2. If I take this one, x1 is 1, x2 is equal to 2, if I substitute here, what I can get? F1 will get. This is corresponding F1. What is that value? 1 square plus 2 square plus 1 plus 4, that will give as a 5. That is a function value. And then if we substitute 3 and 4, then what will happen? 3 square 9 plus 4 square 16. Then how much it will be? 20, like that. So I can get all these values. 5 square means 25 plus 36 and so on. So if you do all this process, what I can get? There is a function matrix, will get it. What is that function matrix? 5 and next value is 20 and so on, you will get it. These are the F1, F2, F3 and so on. How many values if you take? Let it be 4 values, you will get the 4 by 1 matrix, that is a function value. And this matrix is a population matrix, I call it as a, if I take as a 4 values, then we'll get it as a 4 by 2 will get it, 2 columns 4 rows. So now which one is better solution? Our aim is to minimize the function, no? Randomly I taken, and let's consider, for example, this may be another value is 40, this may be 50 or something. Which is the better solution? First one is a better solution. Then your x1 is 1, x2 is 2 and your function value is 5, and compared to all other functions, this will be as a minimum. Once this is a minimum, then what I can get? This value is our final function value at this moment. We are not yet apply ABC algorithm. Initially randomly we pick up. Then we got it as a x1 is 1, x2 is 2, then f is 5. And if you want to find the fitness also, you can find fitness, you can get it as a 1 by 1 plus something f, you can able to get it as a fitness also. So now if you do that fitness, which is more fitness, we will get it as a better solution, or which is the minimum function value, that is also better solution. Obviously because 1 by 1 plus something, no, that will give as a minimum function value, will give as a better fitness value. Now once if you do this, there is a new solution using as a partner solution using some formula. Anyhow, that will come under next slides. So if we do that solution and again if we find the function value and we will compare the old function value and new function value. If the old function value is 5 and new function value is 3, then which one is better? New solution is better, because our objective is minimize this function value. No, I want to minimize this f. So third is a less value compared to the 5. Therefore, second, new solution is a better. So you just select that one is the best solution and discard this. So that is we call it as a greedy selection. Now it is very clear. Greedy selection means that when you are modifying something, you compare the old value and new value. If new value is better than the old value, you retain the new value, or else if the old value is better than the new value, suppose if you do something, you get it as a new value is 10 but old value is 5, then the new solution is worse than the first one. That's why you keep first one or older one is as such and discard the new one. So that we call it as a greedy selection. So this is the employed phase will do this one. So new solution will generate using partner solution based on the formula. Let it be at moment, we don't know what is the formula. And now you compare the old one and new one, which one is a better, that solution you can retain and rest we can discard. That will do as a employed base. Another one, there is onlooker base. So what onlooker base will do is select a food source which is probability is related to the nectar amount, that is a honey amount. So based on the honey amount, we can see that probability you have to select, and again new solution will generate, again greedy selection. So again, while you are forming as a or generating as a new solution, procedure will differ for the employed base case and onlooker B case slightly. And once again, if new solution is better, you can retain, otherwise you can discard the new one. And that is only the selection of a greedy selection. And third procedure, that is a scout bees. So exhausted food source is abandoned and discard and generate a new solution. Suppose this the failures is more, or you can say the trial, anyhow that will come under algorithm. At moment exhausted food source is abandoned, then what will happen? You can discard that solution and generate as a new solution. So like that, all the 3 steps if we complete, that will become as a one iteration, and that iteration will repeat further and further, and until if it be as a constant value, up to that it may be 100 iterations or 50 iterations, and if you do that, final result whatever you are getting, that is the optimal value of x1, x2, x3 and so on, and corresponding function value will give as a minimum function value when compared to all other solutions. So what you want to do is, initially we have to select as a random, and you have to compare. Once if it select as a random solution and you apply employed base, and the new solution will generate, and compare the two things, and whether it is a better or not, you identify using the greedy selection process and you retain that, and that result will pass through the onlooker base phase, and there will also do the more or less similar procedure, and final stage all the food sources means here worst solutions will discard, and finally another solution, the replacement is taking place, and which is the best or minimum solution is obtained, that is our final answer. Like that we need to proceed further. I will explain how the fitness function will calculate what is the greedy selection. Just now I explained how you have to make it as a greedy selection. This one is a old solution value, this is a new solution value. You just find the fitness, which is the more here. Remember one thing, fitness and function value. Our objective is the minimum function, that means maximum fitness. That is the reason we can recall that. If I call it as any one notation, as a function is a minimum value. If I want to compare with fitness, maximum value you have to consider. That is only the thing. Now these two you can compare. If more fitness, second one is more fitness, you can replace that old values to the new values. Otherwise, old values will be retained the same. That is only your what you call it as greedy selection. So anyhow, so a lot of explanation part is there, and we'll see that in the tomorrow class, because it is beyond 4:30. Okay, you can give your attendance and leave.